Okay, so here we are. I'm in a totally blank project. There's nothing in here. First thing we're going to install is the move CLI. And we're going to need the move CLI to basically run our scripts and our modules locally. So I'm following these little instructions which can be found in the move repo language documentation tutorial, and I will link it in here. Just going to use these steps to install the CLI. Now we're going to go into this thing we just cloned and proceed with the necessary dependencies. And then we're going to run this command, cargo install. So now we've installed the move CLI tool. If you haven't got Rust installed on your machine or cargo, I'll leave instructions in some comment to tell you how to install cargo. So for now, all we need to do is to check that move was installed. We're going to do move -- help. And we've got all our help commands coming up, so we know the CLI is installed successfully. Cool. So now I can basically run this command move new, and this will create a new move project for us. So I'm going to call it move one. Okay, cool. So if we have a look in here, let's go into move one. And then we have a look in here. We see we have this move.toml and sources. So if I open this up, our move.toml file is some kind of information about the projects and lists of dependencies. This is like similar to the Rust way it's laid out, if you know about Rust projects. And then inside sources, I've actually got nothing in here right now, just a folder. So here's where I put my source files, the actual move files themselves. So let's add a file, and let's call it first.move. Cool. So there's our first.move, and we're going to write our first module. What is a module, you might ask? A module is a piece of code that's published by an account to run on-chain. It's more or less a smart contract, and there are only two types of code that can run on move, on chains implemented with move, and that is scripts and modules. So we're going to write our module now. So we just write module, and then we write an address, which is the account that is publishing it. So for now, we're just working locally. I'm just going to call it 0x42. Then we're going to call this something. I'm going to call it social network in honor of the origins of this language. Cool. So here we are. This is actually a module now. So basically, let me turn Copilot disable. It's not going to be any help to us here. So first of all, here's our module. We can do a whole bunch of things here. One of the things we can do is declare a struct. And what is a struct? A struct is something that contains, really defines a type of data. You might have come across these in TypeScript and Go. So similar to an object, but this is where we define the shape of the struct, the shape of this data, and what it is. We're going to call it person. So this struct is going to represent a person. I'm going to use these keywords has drop. I will talk about what that means afterwards. So each person is going to have a field. The field is going to be called age. Now, because move is a statically typed language, we need to define all the types of all of our variables. So we're going to say age. What is the age? Age is U8, unsigned integer. So that's our first struct. Pretty cool. And what is this has drop? So has drop means that this person struct can be deleted. If this was to be removed, this would mean that this would not be able to be deleted. And why is that the default? That's the default because we want to ensure resource safety, that these things cannot be deleted. So by explicitly saying that it has drop, it's saying it has the ability to be dropped, and which basically means we're explicitly saying this can be deleted. This is not a valuable resource. If this was not here, any instantiation of this struct would not be able to be deleted. It has to be moved somewhere. So for an NFT, we would want this functionality, right? We wouldn't want an NFT to be just randomly deleted by some weird code. Cool. Now we're going to write this public fun, which stands for public function. And we're going to write the name of the function, which is setAge. And we're going to bring in this new age parameter. So this is the name of the parameter. And then similar to Go or TypeScript, we have to declare the type of the parameter. And then we can write some stuff in our code here. We also need to write if the function returns anything. So we're going to write here U8. So this means that this function is going to return something, and we're going to return the variable of U8. So here we're going to have a new variable called person. This let keyword means that the variable can be altered, it can be changed. It's not a constant, similar to JavaScript uses the let keyword. So this variable is going to be of type person. And here we go. We're going to now instantiate our person. And we're going to give it the age of new age. So basically, this new age that's being passed in will be set as the value of the age field on person, and then we store the person struct inside this variable with a small p. This could be called anything. It could be called Richard, for example. But let's just keep it as person. And then we can just return it. We're not going to return the whole person. We're just going to return the person.age. And similar to Rust, we can, inside the function, we have implicit returns, which means the last thing that is written is returned. If we don't like that, syntax for whatever, let's say we just want our code to be more clearer, we can do this, return person.age, but we can also do that. So that's also cool. And let's say we just want to print out the value of the person age before this. So we just want to actually print out this thing when we run it. Well, we need something like equivalent to a console log or something like this. I mean, this is actually something that's difficult to do in a lot of blockchain-based programming languages, but it's really fine and not a big deal inside Move. So let's, for this, we need to actually use something from the standard library. So we import it, and we're going to import this debug from a standard. So that's how we do it. And we're going to go now debug, and we're going to get the function print. The function print can only take in references to the thing. So person.age, and this ampersand is a reference to the person.age. So it just looks at the address. When I say the address, I don't mean the wallet address, but the place in storage that this person.age is stored at, and then it gives us the value with this ampersand. This is the way the print function works. We need the and on there. So how do we run this? How do we call this? How do we check if our code's working? Well, we're going to go straight away into quite a cool aspect of Move, which is pretty novel actually and totally unique to Move, which is that we can just write really simply unit tests into our module code. So we can just have all the tests right here with our module. So I'm just going to say test, I'm just going to call it test set age. And what we're going to do is just simply call set age for now, and then pass in a number like 10. So this function returns a U8, right? So we should be able to basically go let, let's call it new age. Let's just call it age. And then what we're going to do is just debug print, and we're simply just going to print the age. Cool. So we can run this test. So if we bring up your terminal, and I mean, I'm using NeoVim here, but you can use whatever terminal you want. First of all, we need to build this. So to build this, we just run move build. We get an error. Why do we have an error? Unexpected debug, expected colon. Okay, so that's on line 10. Unexpected debug. Yes, here. So basically, similar to Rust, we need to end all of our statements with the semicolon to sort of explicitly say that this is the end of this statement. Don't join these two statements together. So move build and unexpected debug expected. That's because I forgot it there on the end of this line. Okay, cool. Now we have these new bugs, these new errors. Invalid use unbound module debug. Okay, so what this means is that basically it doesn't know where this debug thing is. We're importing something called debug. We don't know what it is. So if we go to our move.toml, these are our dependencies. So basically, we need to just grab a dependency from somewhere, and what we do is from this thing called move nursery, which is part of the standard library, but we just need to explicitly import it. This is something to note, is that Move is in very early stages. People are developing the frameworks and things, but it's like working in Solidity back in 2014, you know. So cool. So now we've got our move nursery in our move toml file, which actually has all this debug code, you know, attached to the standard library. So let us do move build now. Hey, it built. Okay, let's run now. Move test. Boom. So by running the test, move test, we call our anything with this test sort of tag written above it. Any function underneath this test will be called. So we're actually calling our debug thing here. So basically you can see that this debug is printed and it prints the number 10. So boom. And why are we getting 10 twice? Well, it's because we're also printing it inside the function. So if I just remove that, and now let me clear this, and then move test. There we go, 10. So very simple little intro, but you can already see some really cool stuff. We've got unit tests, and we've got modules. Modules have to have this address. We can call the module something. We can import. And we have these structs, we have these abilities on these structs. In this case, we have to clearly define that it can be dropped, has drop, which means we can delete it, we can remove it. And yeah, we have this nice Rust style syntax with the return, and that's about it. So I think we learn a lot here, and let's go to the next one.